All right, class, so section 6.4 is about trigonometric identities. And we have seen some of the trigonometric identities before and worked with them. Now we're just bringing it all together. So our objectives in this section are to use algebra to simplify trigonometric expressions and establish identities. So two functions are identically equal if f of x equals g of x for all x in the domain for which both functions are defined. Such an equation is referred to as an identity, and any equation that's not an identity is called a conditional equation, but we really aren't going to focus on that. It's just nice little terminology there for you. So here we have, of course, without all the thetas showing up, we have our identities, and why they don't show up, I have no idea. So we have tan of theta is sine of theta over cosine theta, and cotangent of theta is cosine theta over sine of theta. And that comes from our original definition of tangent and cotangent. We have that cosecant of theta is 1 over sine of theta. Again, that comes from our original definition of cosecant. Secant of theta is 1 over cosine of theta, and cotangent of theta is 1 over tangent of theta. We also have that sine squared of theta plus cosine squared theta is 1, and tangent squared of theta plus 1 equals secant theta, secant squared theta, sorry. And the cotangent squared theta plus 1 is cosecant, sorry, plus 1 equals cosecant squared of theta. And these are all listed in the guided note sheet that I gave the class and conveniently in the back cover of most trig textbooks. I also have the even odd identities. So sine of theta and cosecant of theta is odd, as well as tangent and cotangent, and cosecant and secant are even. So if I have sine of negative theta, that equals negative sine of theta. If I have cosecant of negative theta, that equals negative cosecant of theta. If I have cosecant of negative theta, that equals cosecant of theta. If I have cosecant of negative theta, that equals secant of theta. If I have tangent of negative theta, that equals negative tan of theta, because it's odd, right? Thinking back to what we know about even and odd functions and what their graphs look like, right? And if I have cotangent of negative theta, we have negative cotangent of theta. So going back to the graphs of even and odd functions, remember that even functions are symmetric across the y-axis and odd functions are symmetric across the origin. So let's talk about the 4 basic algebraic techniques we're going to be using to establish identities. So first, we're going to be able to establish identities by rewriting trigonometric expressions in terms of just sine and cosine. Next, we're going to multiply our numerator and denominator of a ratio by a very well-chosen 1, something that's going to make it factor nicely when we multiply it. So if I had like 1 minus cosine theta, I might want to multiply that by 1 plus cosine theta, right? That's a product of a sum and a difference, and then we can use our Pythagorean identities. We're also going to practice writing sums of trigonometric ratios as a single ratio, so basically adding fractions and simplifying. And then we're going to factor. Factoring will follow you everywhere, so let's make sure our factoring is on point. So for example 1, I'm going to simplify tangent of theta over secant of theta by rewriting each trigonometric function in terms of sine and cosine functions. So as we discussed, tan of theta over secant of theta. Well, tangent of theta is sine of theta over cosine of theta, and secant of theta is 1 over cosine of theta. Remember when I'm dividing by a fraction, this is a fraction with This is a complex fraction because it has a fraction in the numerator and in the denominator. So I'm going to rewrite this as division because that's really what fractions are doing, is asking us to divide. And when I'm dividing a fraction by another fraction, I keep the first fraction the same, change from division to multiplication, and flip that second fraction. So if I multiply across, we can see our cosines are going to cancel, and I'm just left with sine of theta.